Preventing cognitive decline, how physical activity and mitochondrial health protect against Alzheimer's. Introduction. Alzheimer's disease, a progressive neurodegenerative condition, affects approximately 47 million people worldwide. Experts project that this number could exceed 131 million by 2050, underscoring the urgent need for prevention strategies. Alzheimer's disrupts neuronal communication, impairs memory, and progressively deteriorates brain cells, leading to severe cognitive decline. While no definitive cure exists, emerging research highlights the powerful role of physical activity and mitochondrial health in reducing cognitive decline and promoting long-term brain function. This article explores the profound impact of different types of exercise on brain health, how mitochondrial support influences cognitive resilience, and actionable strategies to protect against Alzheimer's. How physical activity protects the brain. 1. Daily physical activity improves cognitive processing speed. A groundbreaking study from the Penn State College of Medicine demonstrated that regular physical activity, regardless of intensity, improves cognitive processing speed by approximately 60 milliseconds, effectively reducing cognitive age by about 4 years. Processing speed is crucial for problem-solving, decision-making, and adapting to new information, and its decline is a hallmark of cognitive aging. Participants who engaged in daily movement, whether through light walking or moderate activity, demonstrated better reaction times and faster cognitive processing compared to their sedentary counterparts. This evidence suggests that maintaining consistent movement is a powerful defense against cognitive decline. 2. Aerobic exercise enhances neurogenesis and synaptic plasticity. Aerobic exercise, such as brisk walking, jogging, or swimming, significantly boosts brain health by increasing levels of brain-derived neurotrophic factor, BDNF, a critical protein that enhances synaptic plasticity, supports neuronal survival, and promotes neurogenesis in the hippocampus, the brain region associated with memory and learning. Research shows that higher BDNF levels improve spatial learning, visual pattern separation, and working memory. Additionally, aerobic exercise improves cerebral blood flow, delivering oxygen and nutrients that support brain tissue repair and maintenance. 3. Resistance training strengthens cognitive resilience. While aerobic exercise garners much attention for its brain-boosting benefits, resistance training, involving strength-based movements using weights or body resistance, offers equally impressive cognitive benefits, particularly for older adults. Resistance training improves executive function, attention, and memory, even at lower intensities. A study published in the Journal of the American Geriatric Society found that older adults who engaged in resistance training twice weekly experienced enhanced cognitive performance and reduced brain atrophy compared to those who performed only aerobic exercise. Resistance training stimulates growth factors like insulin-like growth factor 1, IGF-1, which support neurogenesis and protect against cognitive decline. The role of mitochondrial health in cognitive function. 1. Mitochondria and brain energy production. Mitochondria are the powerhouse of the cell, producing over 90% of the body's energy, ATP. The brain, despite accounting for only 2% of body weight, consumes 20% of the body's energy to maintain critical functions, including neurotransmission and synaptic plasticity. When mitochondrial function declines, energy production becomes impaired, contributing to oxidative stress, inflammation, and neuronal damage, which accelerate cognitive decline. Supporting mitochondrial health through targeted lifestyle choices and nutrient supplementation can reduce the risk of neurodegeneration and enhance brain resilience. 2. Reducing oxidative stress to protect mitochondria. Oxidative stress, caused by excessive free radicals and reactive oxygen species, ROS, damages mitochondria and accelerates brain aging. Chronic oxidative stress depletes antioxidant defenses, making the brain more vulnerable to damage from environmental toxins and inflammatory processes. Strategies to reduce oxidative stress and support mitochondrial function include consuming antioxidant-rich foods such as berries, green leafy vegetables, and cruciferous vegetables, supplementing with coenzyme Q10, CoQ10, and alpha-lipoic acid, ALA, which protect mitochondrial membranes and reduce oxidative stress, limiting exposure to environmental toxins like pesticides, heavy metals, and air pollutants, all of which damage mitochondrial DNA and contribute to cognitive decline. 3. Enhancing mitochondrial biogenesis. Mitochondrial biogenesis, the process of creating new mitochondria, is essential for maintaining energy production and protecting against neurodegenerative conditions. Regular physical activity enhances mitochondrial biogenesis through the activation of peroxisome proliferator activated receptor gamma coactivator 1 alpha, PGC1 alpha, a key regulator of mitochondrial growth and maintenance. By improving mitochondrial function, physical activity reduces brain inflammation, enhances ATP production, and supports long-term cognitive health. Strategies to protect brain health and prevent cognitive decline. 1. Incorporate regular aerobic and resistance training. Engage in at least 150 minutes of moderate intensity aerobic exercise and 2 sessions of resistance training weekly. Activities such as walking, swimming, strength training, and yoga contribute to enhanced brain function and reduced cognitive decline. 2. Support mitochondrial health with targeted nutrients. Nutrient-rich foods and targeted supplements can improve mitochondrial function and combat oxidative stress. Key nutrients include coenzyme Q10, CoQ10, enhances mitochondrial energy production and protects against oxidative damage. Alpha-lipoic acid, ALA, reduces oxidative stress and improves mitochondrial efficiency. Magnesium supports mitochondrial ATP synthesis and promotes brain relaxation. B vitamins B1, B6, B12 enhance mitochondrial metabolism and support nerve health. 3. Optimize brain function through intermittent fasting. Intermittent fasting, IF, promotes mitochondrial health by triggering autophagy, a process that removes damaged cells and stimulates cellular regeneration. Fasting enhances ketone production, an alternative energy source that fuels brain cells and protects against neurodegeneration. 4. Prioritize quality sleep for brain repair. Sleep is critical for cognitive restoration and memory consolidation. Poor sleep impairs mitochondrial function, increases inflammation, and accelerates brain aging. Prioritize 7 to 9 hours of quality sleep per night by maintaining a consistent sleep schedule and minimizing blue light exposure before bed. 5. Manage stress and inflammation. Chronic stress elevates cortisol, which impairs mitochondrial function and promotes oxidative damage. Incorporate stress management techniques such as meditation and deep breathing exercises to reduce cortisol levels, yoga and Tai Chi to enhance parasympathetic nervous system activity. Conclusion: preventing cognitive decline requires a multifaceted approach that integrates physical activity, mitochondrial health, and targeted lifestyle interventions. Aerobic and resistance exercises improve brain function by boosting BDNF, enhancing synaptic plasticity, and supporting neurogenesis. Simultaneously, protecting mitochondria through antioxidant support, reducing oxidative stress, and promoting mitochondrial biogenesis plays a crucial role in maintaining cognitive resilience. By incorporating consistent physical activity, optimizing nutrient intake, and minimizing exposure to environmental toxins, individuals can protect their brain health, reduce the risk of Alzheimer's disease, and promote long-term cognitive well-being.